as we begin the next part of this unit on photosynthesis and respiration, I want you to think about respiration and what you think of when you hear the word respiration. Many students will say they think of breathing, they think of oxygen, and those are great answers. Respiration does deal with those. And the reason that we call it cellular respiration, it's not that your cells are breathing, but your cells need oxygen. And they are taking the oxygen and they are going to be converting it to energy. Now, plants have to start with making the food. Once the food is made, then the food and the oxygen will make energy. So the plants have to go through photosynthesis, and then they have to go through cellular respiration. You and I, we eat food, and we don't go through photosynthesis, and then we can go through cellular respiration. Cellular respiration has multiple steps. Everybody starts with the same step, though. Step number 1 is always going to be glycolysis. Now, we've seen the word lysis before. It means to cut, like hydrolysis. Glycolysis is going to deal with glucose, and it's going to cut glucose. So again, if you know some key suffixes or prefixes, that can really help you throughout science and learning other words. So the first step in releasing this food energy, glucose, is to take the glucose and break it apart. And when we break it apart, the molecule that we're making is pyruvic acid. So we take a glucose, we break it apart. So now we have 2 of them, and those are called pyruvic acid. That is step number 1, and that happens the same for all individuals and all plants. Everything has to go through glycolysis. That's important. That is absolutely the first step. Some issues, some just facts about glycolysis. First, it doesn't require any oxygen. You go through glycolysis at any point in time, whether you're holding your breath, you have plenty of oxygen or not. This doesn't require any oxygen, okay, this portion of it. And it also takes place in your cytoplasm. So the cytoplasm, again, that jelly-like substance, holds your organelles in place. This is not the mitochondria. This is not the powerhouse. So there's not a lot of energy that is being made here with the glucose getting cut. At most, you're getting 2 ATP molecules. Remember, ATP is our fully charged battery. It's the one that has the 3 phosphates and can give us the most energy. But 2 ATP is not very many. It's not going to last very long. And then lastly, we have a new energy carrier. So notice now we have NAD positive. So again, when you see the positive, that just tells you it's empty, and it can accept 2 high energy electrons, and when it does so, you just drop the positive and you put an H, so it can hold the 2 electrons and a hydrogen. Now from here, your body has to decide what step comes next, and this is something that we'll put up on the board. But glycolysis happens first. This is step number 1. And step number 2 is going to depend on where your body is at with the amount of oxygen that you have. So if you are, you don't have enough oxygen, so you're not like you're without oxygen and you're, going to die, but possibly if you're running a race and you're using up your oxygen quicker than what you can do this process, then this is what we mean by without oxygen. Certain cardiovascular sports go through this side here after glycolysis because they're not getting enough oxygen. And then we have the with oxygen side, and that just means that you're breathing in enough oxygen to support the next process. So we're going to take a look at this without oxygen side. Again, this isn't the side that we're always on. We kind of flip back and forth between these two depending on the with or without oxygen. So step number 2, if there's no oxygen present or not enough, then step number 2 is called fermentation. And fermentation is a way for us to gain energy, okay, from the food that we're eating, but we're gaining that energy and we're producing ATP, but we're doing it without oxygen or without enough oxygen to fully support the other system. So fermentation is not the best of choices, but it is something that for short periods of time we've all experienced. Anaerobic activity is just an activity that we say doesn't require oxygen. Again, it's not that you're holding your breath to do this activity, but it's just not something that you're going to be doing for a long enough period of time that you're going to build up a problem here. You're going to have enough oxygen to support you. There are two types of fermentation, and these, depending on what type of living organism you are, you do one or the other. So one is called alcoholic fermentation, the other one is lactic acid fermentation. We'll look at alcoholic first because that is the one that we do not do as humans. Alcoholic fermentation is produced by yeast and other microscopic organisms. So this is not one that we as humans, our cells cannot perform this. And the reason that it's called alcoholic fermentation is that they do produce or make ethyl alcohol. They also make carbon dioxide. And these are considered waste products. So for people who own breweries and things, they have learned how to kind of capitalize on this alcohol that's being produced by the yeast or microscopic organisms to make lots and lots of money. But you and I as humans do not perform alcoholic fermentation. The equation for this would look like pyruvic acid. And again, pyruvic acid was made in glycolysis, so that has to happen first because we need the pyruvic acid for step number 2. We have electrons in our electron carrier, and these electrons with the pyruvic acid will make alcohol, carbon dioxide, and our electron carrier becomes empty because those electrons are going to get used up. The energy is going to get used up. The yeast that we use in bread, if you've ever made homemade bread or seen it, has to rise before you can bake it in the oven. And the yeast in the bread produces carbon dioxide. That's one of the products from the previous screen, and carbon dioxide is a gas. And the gas wants to find its way out of your bread dough. And so as it's escaping, it's trying to come out of the bread through the top of it. That causes the bread, it kind of pulls the bread up as the carbon dioxide moves up. And that's why sometimes you'll also get like pockets of empty space in your bread, and that's because there was probably a carbon dioxide bubble, a bunch of gas kind of all collected right there. And so your bread wasn't rising because there was this big gas bubble in the way. And lactic acid fermentation, this is what you and I as humans, as animal cells, this is what our cells will make when we don't have enough oxygen to perform cellular respiration. Lactic acid fermentation will take pyruvic acid and our electron carrier, and it makes lactic acid. That's where the name comes from. Now those of you that have had strength training or you do any type of aerobic activity, your muscles during certain rapid exercises will produce lactic acid. And lactic acid is an acid. It makes your muscles feel very, very sore, and this is only when your body can't supply oxygen to your cells quick enough to make energy through cellular respiration. So again, this isn't something that you experience, all the time. Only during certain instances. But lactic acid will build up in your muscles. It will give you this feeling of a burning sensation. So maybe you're lifting weights and you're doing several repetitions of that. Eventually your muscles feel like they're burning, like they're on fire. I'm hurting. And this isn't like hurting, I need to go to the doctor because I think I sprained or tore something. This is just, that ache, that soreness that you get in your muscles. That would be this lactic acid that's building up. And as soon as you're done with the activity and you can go back to breathing, you're getting oxygen to your cells fast enough to do cellular respiration, then the lactic acid breaks down, it goes away, and you don't feel that burning sensation. We're not talking about the next day your muscles feel sore. That is not lactic acid. Lactic acid does not stay in your muscles for that length of a time. Okay, it's a very short-lived. Lactic acid can also be used to produce foods that you might eat, and a lot of these can be produced through other acids, so it's not just lactic acid, but you can take vinegar, which has acetic acid, and they help make some of these, like pickles, for instance. Take cucumbers, add vinegar and spices or whatever, if you want dill pickles versus sweet pickles, and you can make pickles. You can do this with cheese and yogurt. Okay, take different dairy products and they add different acids at different points in the process to be able to make these. Sauerkraut, for instance, comes from cabbage. They've shredded up and they add an acid to, and then that kind of helps to create the sauerkraut. So lactic acid, acid in general, has several uses for us, but that is something that all of us probably have experienced, lactic acid fermentation.